Let me start sharing my slides. I want to replace, I believe. Where is it? Here. Okay. So, yes, I hope you can see my screen. And yes, today I will present the first of the 3 projects that are represented today. The AI Effect Project, which is one of the testing and experimentation facilities funded by the European Commission, together with the EnerTEF and EnergyGuard. And I also tried to include some slides at the end, since I saw that, and thanks for starting that, I saw there was a poll for the participants on what they expect to see, and I tried to bring some examples of what the TEF, in this case AI Effect, offers as services for AI developers as well as utilities. Let me start by, first of all, explaining what is the motivation or the background for AI Effect, but I think in general all the TEF projects. We are all aware that AI is a very hot topic. It's changing our lives on a everyday basis, and it's also changing, of course, the energy sector. And we see, as researchers or as industry, some challenges posed by the rapid development of AI, as well as the regulatory framework around the adoption of AI in environments or in systems like the energy system, which is classified as a critical system. So one is the AI Act, the regulations, the risk management, the quality management that it requires, especially for high risk systems like the electricity system. So that's one challenge. The second one is more from the industry point of view, on the trustworthiness that should be guaranteed on AI solutions to be adopted and used to replace maybe business as usual solutions that are known and thus trusted by the industry or by the utilities. And the third one, which is probably whenever talking about challenges about AI and AI development, is the very first one that comes out, is accessing data, good quality of data, data that are representative of real cases or real scenarios, as well as accessing data that maybe are for one way or another, for one reason or another, for security, for privacy reasons, not so easy to share or to grant access to externals, especially for utilities. That's a huge challenge. These are the 3 challenges that a TEF and the effect in my case is trying to address by providing a framework for building trust, for having compliance or be able to do compliance tests, as well as secure data access provision to all the involved stakeholders. From the utilities point of view, I said AI is a big thing. It's changing, or it's being introduced in many also operational situations within utilities. And it's a great opportunity, especially to address new problems that utilities in the energy sector are facing. On the other hand, the need for understanding what AI solutions do, how they behave, and how they can be trusted is a big need from the utility, especially when they have to then be the responsible ones for the behavior of their systems. From the industry, AI developers, I mentioned access to realistic data sets, especially for training purposes, is a big challenge or is a big need, but also understanding what their clients, their customers need and want to have. So what type of problems they want to solve, what type of solutions they are looking at, and what needs are the primary ones. For this reason, we envisioned AI Effect with some key strategic objectives. The very first one was to address a specific use case or start our development and design of the TEF based on real use cases that are strategic for the energy industry today. Based on that, we defined a modular and scalable framework with interoperability at its core to facilitate data access, to facilitate also expansion or adaptation to different use cases. The third one is then to put together this modular framework to provide an end-to-end validation and testing solution for AI. So from the training of the AI agents, the benchmarking, and then the validation against specific technical KPIs as well as regulatory requirements. We also envision a governance and business model for the TEF itself, understanding who participates and how, who has benefits, who should sustain, for example, costs, and sustain the architecture and effect beyond the project. And finally, we want to engage with all European and global energy stakeholders, not only the ones in the consortium, not only the ones that have an interest, but we really want to reach out to all the industry because we believe that's a key point for making infrastructures like the TEF sustainable and future-proof. Our vision, I mentioned already, we envision a modular and scalable architecture. We started with 4 nodes, so 4 distributed nodes where we developed the use cases from utility needs. We want this architecture to be open and free, so accessing the TEF during the project is open, or we want to facilitate openness to the datasets for training, to the benchmarking, and the TEF services. It is highly based on collaborative efforts because each node has the know-how coming from research institutions or universities, has the computing and laboratory capabilities, has the needs and understanding from the utility side on what are the requirements, as well as from the AI developers and startups for providing solutions. It is based on the use cases to show that when the development is based on real needs, then the value it brings to all the stakeholders is worth extending these capabilities beyond those initial use cases. And finally, we have also an attention to regulatory compliancy, especially with respect to the EU AI Act. I mentioned we have 4 nodes, so they are distributed. They are in 4 different countries in Europe. We have the Danish node, where we look at sector coupling and district heating. We have the Dutch node, where we assess the transmission system congestion management applications. We have a German node, where we look at DR integration in distribution systems. And finally, the Portuguese node, that focuses on energy communities and data space connectors. These decentralized nodes are anyway interconnected on the upper level of the effect platform with a central entry point, which is the virtual platform of the project, where we maintain the catalog of services, where we do the onboarding of services, and also where the stakeholders, like the utilities, can jump in, propose new use cases, new testing scenarios, or AI developers can train their models and propose their solutions. In fact, I mentioned 2 levels of architecture. The one in the bottom is what we call nodes. So we have these distributed nodes where we have data sets coming from utilities. We have the AI tools coming from AI developers. And the node has all the capabilities for interconnecting and sharing data in a secure way, has the simulation capabilities, data processing, power system modeling, know-how, and all the infrastructure for keeping together or putting together all these decentralized components. On the upper level, we have the central platform where we mainly maintain the EF catalog, so the catalog of services that the TEF offers. We also offer an onboarding process for new tools, new services, and datasets. Those end up in the catalog and are offered to whoever wants to either test their solutions or propose new use cases and test cases. We define test cases in terms of technical test cases, as well as, for example, trustworthiness or AI explainability test cases. And we provide the compliance or certification process against those specific test cases and the related performance indicator. The digital platform is designed in a way that the entry point is the central platform, and then depending on the use case or depending on the test case that a utility or an AI tool developer want to validate, then it's instantiated in the specific node. I will focus on one of our nodes, the German one in this case. I mentioned it's about DR integration, so we are looking at integration of renewables in distribution system and how to manage congestions related to DR integration. Here we test within the project a specific AI agent that is able to steer the different flexible resources or the control points in order to avoid congestions. And the key activities we're developing, or we have been developing in the first 18 months of the project, and we want to complete in the next 18, are indeed offering services for training an AI agent, and then, for example, benchmarking it against a reference implementation or the utility requirements. And that's what I'm going to show right now. So the architecture of the German node is we have the computing and simulation capabilities in Germany, hosted by Fraunhofer, where we have the virtual machine, all the software for the simulation, OpenDSS from EPRI, Grid2Op for the scenarios definition. All of this, it's put together in the physical node in Germany. And then we have data provision services. Data provision services that are meant to connect on one hand to the data provider, in this case it's Enel, Italian DSO, and on the other hand to the AI tool and the AI agent coming from Enlight AI. Then on the upper level, there is the orchestration of the TEF services, the local ones that we want to run, and the catalog and the TEF policy, for example, for access to data. Let me give you two quick examples of what we are doing. The first one is how we run the training of an AI agent. So I will try to focus on the main steps here, but what you see here on the left, there is the TEF, so the central part of the EF TEF, where we have the benchmark, where we have the catalog of services, the data and data access policies. On the extreme left, we have the Enel database, which resides within the premises of the data owner, in this case, as a precise design choice. In the middle, we have the German node, so the physical infrastructure hosted by Fraunhofer in Germany, where we run the core of the simulation, scenarios execution, and benchmarking. And on the right side, there is the premise of the AI vendor. So their agent is not transferred to anyone else or to the TEF. It's kept locally, and the TEF takes care of transferring the data for the execution. So the very first step for the training is for the a vendor to access the TEF repository and download the training data as well as the challenge for the training. Once this happens, then the vendor can provide the training data to the node, so the data and the agent connection, and we generate scenarios on a time-based simulation where we have the testing data. We generate scenarios, different scenarios, for example, for congestion or for different ratios of DR integration, and we execute this at each time step and provide powerful calculation and the full grid state to the AI agent. Then the AI agent computes the situation. So, for example, identifies if there is a congestion or not. And in case there is a congestion, it provides corrective actions. Those corrective actions are then executed in the simulation environment, and feedback is provided on how good they were performing to the agent. By this, closing this loop, the AI agent is able to evaluate how good the strategy is working and eventually update it and complete the training. Once this is completed, then the AI developer, in this case AI Light, obtains a trained agent that has been trained on real data coming from utility, on a real use case that they defined, and a subset of test scenarios that were used for the training. The next step that we can offer, in this case again on the same environment, is then the benchmarking of an AI agent. Similar situation, we have data source, we have the centralized TEF, we are going to use different services this time, the German node infrastructure, and the AI vendor. In this case, when an AI developer wants to benchmark their AI agent against a reference implementation, then they request a benchmarking session, upload the challenge that they want to address, and receive the benchmark data. So the data set as well as the evaluation KPIs. Once this is transferred to the TEF node, similar to what we saw before, the real-time simulation or the simulation is executed, and the power flow is calculated and provided to the trained already AI agent. The agent in this case needs to identify congestions and propose corrective actions. We don't have the loop we had before for the training on adapting the strategy, but it executes the full test case, and then the node acquires all the execution and sends it back to the TEF benchmarking system and service, where the execution of this agent, so its performance, is tested and validated against reference implementation or other, for example, trained agents, and provides back benchmark result to the AI vendor. In this case, this output or this knowledge allows them to understand how good they perform with respect to, for example, already used solution within a specific utility, and understand how good they are with respect to the benchmark, and how to eventually approach a prospective customer offering a solution that outperforms what they have as a reference implementation. I wanted to present these two concrete cases to give an understanding of what a TEF does, what we, in this case, provide in terms of services for the TEF and for the different stakeholders. I hope it was interesting and clear, and I will close here, but I'm happy to take any question if you have any. I don't know if we have time right now or during the rest of the webinar. So thanks for your attention.
Thank you, Gianluca, for the presentation. Here, there is a question from the audience. Perhaps we can take the questions at the end. Would you prefer that at the discussion point?
Yeah, fine for me. If we want to go forward.
In the meantime, you can see the question that has been posted. Okay.
Perfect.
Yes. Elissaios has been in, but has also gone out for some reason. So we may proceed to the next Spiros Mousakidis, why use EnergyGuard, and then go back to Elissaios. Elissaios is in. So, okay. So Elissaios can present in his slot. Sorry?
I had some problems with my connection, but...
Okay.
Is everything fine now? Is it
yeah,
okay?
I hope it is. Can you hear me? Can you see me?
Yes, we can, and we can hear you as well.
I think the EnergyGuard is already shared, so Spiros, you can go and I can go next if you want.
Oh, okay.
Good.
Okay, so hello to everyone. I will present you the EnergyGuard project. Let me check. I don't know, you can hear me, right? Yeah.
Perfect.
Okay, so we will start with a question. Okay, do you know that 60% of research-grade AI never reaches industry? So almost more than half of the AI solutions never start to go to the market, and they are not commercialized. And why is that? Because as you have seen the last years, we are currently living in what I call the Wild West of AI. As you have seen now, every day, new products, new AI tools of unknown trustworthiness and lawfulness. You have seen also cases like there are a lot of personal AI assistants that are now like the mold crawler, that basically you give access to everything in order for them to work. So both from the AI developers as well as the side from the people from the energy industry, from the energy sector, they have a fear of missing out. But there is a lack of trust for their adoption, let alone for critical infrastructure, like the energy sector is. There are huge risks of untrustworthy AI applications in the energy sector, because the decision making there has significant financial, environmental, and societal implications. Besides that, the energy sector is one of the top 3 target sector for attacks. You have seen also a lot of cases where living in times where the energy infrastructure is getting more attacks the last years, and the AI actually has enabled the attacks to become more sophisticated and to find new attack vectors. So there is also the advancements of smart grids that are more connected to the internet. So this exposes even more vulnerabilities to the infrastructure and the systems of the energy sector. So what are some main problems for the AI developers? They have a lot of challenges. There is a lack of access to the data and the infrastructure. Especially, you cannot simply run experiments on a live plant on a live grid. There is a high cost of the testing environments. There are limited budgets to do that, especially for SMEs and startups. There are a huge experimentation validation costs. There are expertise gaps. Things are moving so fast that you are not even able to keep track of what is going on and the new products that come out in the market. And at the same time, we live in a very dynamic and ever-changing regulatory environment where there are many changes in terms of regulation. So people need to have some guidance on how to keep and how to easier bring their AI products to the market in a way that they're also trustworthy. So this brings also issues about the adoption and sustainability. There is a resistance to the change, lack of incentives, and sometimes also a real also problem that a lot of companies have, that they think on the hype. So a lot of the new products, they are maybe just wrappers to, for instance, LLMs or other AI tools. So they don't have seen the real conditions and the real challenges of the energy sector needs. So this is where EnergyGuard comes in, and our vision is to develop and operate an open and robust experimentation facility that actually empowers the developers and SMEs to validate the products under real-world conditions and in a cost-effective way, in order to boost the energy sector market with trustworthy AI solutions that can be adopted. Okay, we started a little bit later than the other 2 TEF, and we started in the beginning of 25 and 3 years of duration, and we are 16 partners from 9 countries, and actually half of the partners are SMEs working on AI solutions, as well as stakeholders from the energy sector. So our first objective is to create the testing experimentation facility for the AI application in the energy sector, backed by high-performance computing, to deliver a range of tools and services to the AI innovators in order to build an AI pipelines to be able to experiment in a safe environment, provide an environment for assessing the trustworthiness and ensuring the quality of the AI solutions, as well as creating a publicly disclosed database of ethical and systemic AI risk related and tailored to the energy system. So EnergyGuard brings 5 top existing large-scale testing and experimentation facilities that cover the full energy value chain and energy vectors. We have SEA Lit and Blue Energy and EnerTEF TEF. We are bringing hydrogen testing platforms that includes different types of electrolyzers. We have Riga Energy Agency, along with the State Control Bureau of Latvia, that we have a network of multi-apartment residential buildings. We have SEDER CMAT, a smart microgrid with distributed energy resources, and then Green, which brings the Antrodoco renewable energy community. Lastly, we have a digital twin of the Portuguese transmission network by RD Nestor. And all these facilities are being supported by Meluxina, provided by Lux Provide. So these facilities cover the full range of the energy value chain. So the transmission system operators, distribution system operators, end users, members from the renewable energy community, and across different energy vectors, electricity, hydrogen, heating. And these include a lot of components, and thus a lot of components under real conditions, like the transmission network components, smart grid assets, hydro power plants, wind power, photovoltaic systems, electrical vehicles, and batteries systems, and so on. And what is our approach? Our approach is to take a digital twin of these assets from the existing physical and virtual facilities. We break them in a data lake, and thereafter the user, you can find and play with them in a sandbox testing environment when you can run your experiments based on popular tools that data scientists already working, like MLflow and Jupyter. And we have a trustworthy AI acceptance environment where basically you're conducting assessment based on robustness, performance of the models, code quality analysis, and a different range of other trustworthy AI assessment tools. And the idea is to increase the uptake of trustworthy AI across Europe and have a better enhanced grid management reliability, better renewable energy systems management optimization, and in general, to be able to make these validations and enhancements of your models and your AI services in a cost-effective manner. So this is our user journey. The user submits an application for the EnergyGuard services and specifies the assets that they need. Once the application is approved, you're entering the sandbox environment where you have access now to the assets from the real-world operational environments through the relevant digital twin, data, models, APIs, and applications, and services relevant, for instance, forecasting service that you can benchmark your models against it. Then the end user can monitor and evaluate and compare the output of each experiment and see how it performs under different runs and create new versions of these models. And then the user can return to the design and build phase in order to further improve their AI solution. And the AI solution there is going in a holistic validation trustworthy assessment, as I said before, across different aspects, vulnerabilities, explainability, fairness, and as well as with the human in the loop assessment. And then it can go through a loop and improve their experiment and services. And once the product passes acceptable threshold, they are able to launch their product. And we aim to promote the marketplace currently being built by Europe, including the AI demand platform. So this is an example of an AI application as a use case of the test and experimentation facility. We have an energy efficiency tool. Basically, it's an AI-driven decision support application for building energy retrofit planning in Riga, in Latvia. So, in a nutshell, the user enters the they select the renovation measures, and then they get a simulated energy performance results after renovation. So such an application can benefit from the TEF by getting more data, so they can test their applications in real world conditions coming from real data coming from buildings, and they can enhance the model with different type of buildings that they can find. They can take advantage of the HPC resources offered by Meluxina in order to run very complicated and resources intense models, as well as the integration of, for instance, LLMs and AI agents in order to improve and test their applications. They can have multiple performance evaluation and validation of services, additional model outputs. And these use cases that will also be integrated in the platform, so people can measure the performance of their service also utilizing this tool. Another use case is for the forecast by a digital twin of a large-scale electricity grid. So the idea here is there is a service called DeepTSF, which actually uses state-of-the-art models, both based on machine learning models like the GBM decision trees, as well as deep learning models like NBITS. So it has already the state-of-the-art in terms of the performance of the models of forecasting. And the idea here is to generate forecast of load and renewable energy generation for 1,000 nodes of the Portuguese transmission network digital twin. So by utilizing, by bringing, for instance, by an AI developer bringing a forecast tool, they can test their forecasting in under real conditions. And they can also utilize the DeepTSF in order to benchmark and evaluate their tool against the state of the art. And so you can feed the forecast in the transmission network digital twin and run the grid analysis under realistic conditions. And thereafter, you can combine the forecast with the market results, the actual demand and response by the market, in order to detect outliers or potential grid constraint violations. All our test and experimentation facility, we want it to be in full alignment with the EU ecosystem. We see ourselves that AI factories will be responsible for the development of the models and the training and the AI services. EnergyGuard comes to test and experiment in real conditions before market. This is our main alignment. And we want to connect also with the nodes of the other energy tests that you have seen, and you will see also in the next presentation, to bring assets, especially regarding the energy sector, environmental services, and weather data, for instance, from the data spaces, and deploy and promote the services and the marketplace of the on-demand platform. So one hand, deploy to the marketplace, the products, as well as enhance the trustworthiness of the EU service infrastructure, meaning in case we see that they are using models or resources that have constraints or vector logins, how they can improve that, and how to connect also to the European AI network and to find more appropriate and more independent solutions. So this is in a nutshell. We're expecting the platform the beta version to come on June this year, and you can find us also on our website and join our waiting list. So thank you very much.
Well, thank you. There are also two questions, but since we have been a little bit late, I would suggest that these questions be put at the end, at the question and answering discussion panel. Elissaios, are you ready for your?
Yes. Can you
Yes,
see my
okay.
screen?
Yes, we can. So this is how can you use EnerTEF by Elissaios Sarmas.
Okay. Good morning, everyone. I'd like to thank you, all of you, for joining. Almost 60 people. I'm very happy with this attendance here today. I'm complementing the previous presentations by my good colleagues, Spiros and Gianluca, and I would like here to present the third sister project of this series, which is called EnerTEF. Here are a few administrative details about the project. So the title of the project is the Common European Scale Energy AI Federated TEF, Testing and Experimentation Facility. We started at the beginning of November of 2024, and the project has a duration of a total of 3 years. In general, there are 25 participants in the consortium, split across 10 different European EU countries. And here you can see the synthesis. So our laboratory, the Energy Policy Unit Laboratory of NTUA, acts as the coordinator. The technical coordination is led by the very well-known company European Dynamics. We have, for the business modeling part, which is essential for the project, the PwC. And then there are the TEF nodes and the TEF satellites based on our terminology. We have a renewables node, we have a buildings one, an electricity and mobility part, EVs, a distribution system operators related node, transmission one, and 3 satellites related to district heating, to industrial processes and flexibility, and of course to green hydrogen production.
Elissaios, we see only your first slide. We don't see you.
Really?
Yes.
I don't know why, I'm not sure. I will try to, let's say, to reshare maybe the whole screen.
Maybe share the whole screen.
Yeah. Now we are in the goals. Please go ahead.
Now better?
We see the goals now.
You see the goals?
Yeah.
Okay. So the primary goal, let's say, is to establish this federated infrastructure, which would assist in facilitating an extensive adoption, a validation, and the upscaling of artificial intelligence tools and services across the energy sector. So the ecosystem is composed of 5 nodes and 3 satellites, as I told you before, and there are 3 main dimensions. First and foremost is the testing of these services. Second one is to promote trustworthiness in artificial intelligence. And third one is to move from laboratory experiments to real-world environments. Can you see this next slide with the scope?
Yes. Yes, we can.
Can you? Okay,
yes.
Perfect. So the scope, we bring together a variety of physical and of digital facilities, of digital twins, of high-performance computing resources in order to drive innovation in the artificial intelligence sector. So there is organized a big network, 5 nodes of 3 satellites across the whole Europe, and the stakeholders span through the whole energy value chain. We have TSOs, DSOs, utilities, RES operators, aggregators, demand aggregators, and also technology developers. Here is an illustration of the whole environment. You can see the different nodes, the different satellites, and what each node and each satellite focuses on. So we have a renewables one for energy system operators with PPC and Core Power Ocean from Portugal. We have an e-mobility node for smart electricity vehicle charging and storage in energy communities. We have this DSO one for distribution system operators in Germany, the TSO with LS for proactive provision of high voltage services, buildings node, flexibility and demand response, and the 3 satellites. The timeline, we started at the 1st of November of 2024, as we told you. Now we are in the 16th month, February 2026, and we have already provided the first version of the testing services catalog for the AI solutions, as well as the first wave of the services themselves, the solutions. So we have prepared an ML workbench, an HPC orchestrator, an ontology creator, and also a big list of AI services. Here you can see the whole time plan until the end of the project, which aims to finalize at October 2027 with the attraction of funding schemes and a nice business plan for going to the market and living also after the project termination. So here are the roles and the roadmap. You can see that there are different roles. We have the role of end user, which is supposed to be an energy domain expert. We have the role of AI service developers, which are SMEs, startups working on the solutions. The node provider, of course, which provides the physical assets, and the node administrator, which provides the computational resources and the whole support on the AI model development. And there are then the secondary roles, which are horizontal, let's say, national and EU authorities, the regulatory part with an approach of having some protected demonstrations, business modeling, and certification audit. So here you can see also the steps. We started with the creation of AI living labs. We moved towards bridging a centralized access via the EnerTEF portal, then to try to promote a seamless integration of the federated nodes and satellites in this portal. We are in the process of achieving that. Then step 4, the development of the services, and of course, our go-to-market strategy. Here is the structure, the whole architecture. You can see in the middle of the screen the marketplace with the transaction manager, the user interface, recommendation engine, the whole catalog of the services, as well as the regulatory sandbox that we have adopted. And you can see that under that, there's the experimentation hub where we have the whole HPC resources of the nodes. We have the experiment workbench, the orchestrator that orchestrates the different tasks, the different activities across the nodes, and federated on that there are the different nodes, the different TEFs with their local digital twins, their local platforms, their physical assets, their digital assets, and their data sets. On top of everything, we have a very secure identity access manager with SSO, and we have also an access policy that allows only the more specific part to be visible throughout the whole network. Of course, all of this is supported by our middleware at the bottom of the screen with the data spaces. We have adopted the connector as a service approach where we manage to set up different connectors in the different federated nodes and satellites in order to promote a secure data sharing. And here are some results to finish with. The EnerTEF portal is already available, so a first version is already there, so visitors can join, can see the services, can navigate through it. We have some data also available from photovoltaic parks, from hydroelectric power plants, from wind farms, in order to promote services such as the monitoring of multiple hydroelectric plants, time series data with records per plant by BPC, the monitoring of entire wind farms and individual wind turbines, a big record of over 50K datasets. And also in the photovoltaic sector, we have the multi-layer PV monitoring, energy and power analysis of each individual park. Here are some nodes, federated ones that we have managed to set up. You can see in the left the digital twinning part of the district heating network, which allows for services related to real-time optimization of the network itself. You have some data platforms. For example, in the middle of the screen, you can see a real-time municipal buildings consumption and rooftop production monitoring platform. And of course, we have this Oasis platform at the right, which provides access to real sensors from renewables and also has an LLM assistant in order to provide questions and answers related to the explainability of these datasets. Last but not least, our EnerTEF services catalog is live. Over 40 services are there with 5 nodes and 3 satellites. You can see some examples. For example, we have this AI-driven fault detection, classification, and transmission grids. We have this TSO-DSO coordination service, battery and e-mobility EMS optimization for PV self-consumption optimization, and also some other services related to wind power forecasting, to hydropower forecasting, to offshore renewables, etc. You can find all of these available at the link enertef.eu. Please try to visit it. And I think that's all from my side. And thank you all for your interest once again. I hope we remain in touch for the next step, and feel free to come and experiment with our portal. Thank you.
Well, thank you very much, Elissaios. I think we have just 10 minutes for the questions and answers discussion panel. There are still some open questions. There is one to Dr. Moussakitis by Marwa Magni for the HPC service. How do you ensure that the data centers that host the HPC activity are sustainable and do not negatively affect the water supply of nearby communities? But I see that Dr. Moussakitis is typing an answer.
I can say it now.
Yes.
Okay, this is a very good question, because part of our job as test and experimentation facilities also is to look at the redundant use of AI. We see a lot of cases, and a lot of clients come and said that let's do something in AI, where you could do it in another way, in a more efficient way, with utilizing less resources. Or instead of using a very specific small model, they are using huge models. There's a lot of redundancy. And part of our objective is also to work towards sustainability and minimize the resources used. In the particular question of how we ensure, we don't plan to create new data centers. We are based on Meluxina, as I said before, that has actually been renowned as one of the greenest infrastructures in Europe, because they are using modern technology and modern infrastructure. And it's one of our main concerns also to have a sustainable AI solutions out there. It's part of the trustworthiness. I can answer also the second one.
Yes.
Is the transmission level digital twin run with RDTS or PAL-RT? This is actually a tool by RD Nester. It's real-time power simulation, and it's based on PAL-RT, so it's real-time simulations, not just software. But you can find more questions. You can send us an email if you want to find more about the simulation that they use and the details about the simulation. So, okay, that's it from my side.
Okay, thank you very much. And there is one more question here that has not been answered. Will there be further alignment between TEFs emerge at some point?
This is a very nice question, if I can start.
Yes,
we're working towards that. The Commission also has required this alignment between the activities, not to work in isolation from one another. Now, all three TEFs are moving towards their first reporting period, so we'll have our review in the upcoming months. We will discuss that with the Commission. The idea is to have a first layer of soft integration, a single access to the three TEFs after the end of the project. We have aligned with that with the three consortia, but then also in the technical backbone, in terms of interoperability and all this stuff, I think it would be a very nice initiative, and the question is in the correct direction, because many times these projects work in isolation from one another, and the results most of the times remain, let's say, fragmented. So after the end of the 3 years, many of the key exploitable results tend to die together with the project. But now we have very good collaboration between the three of us. All the consortia, are working together on that to promote the long-term sustainability, viability of the TEFs, as the call also required. Also, Spiro, Gianluca, if you want to add something.
Maybe I will just complement because there was a similar question also from Antoine. It's nice that both questions are coming, let's say, from operators, which are one of the key stakeholders also in making these sustainable, as you said. And I find it interesting that three different proposals, three different projects, okay, answers to the same call, but as you said, the foundation or the technical approach, it's very similar. So even without coordinating initially in the proposal, we do share a vision of how the architecture is made. We see the importance of having data interfaces within the nodes. Probably then the next step, as you said, it's which is also fostered by the Commission, is understanding what is the between TEF interoperability challenges that are there, what could be the ways to overcome them, and would be, I think, a very, very nice win also for the TEFs as well as the Commission, if at the end of the projects we could show that one an interaction between the different nodes is possible by just implementing the right interoperability mechanisms. I think its strength can give strength to all the TEFs or as a united single TEF.
Yes. I agree with both of you. As I had in my slides, it's very vital for us also to make the connection with the nodes, as Elissaios said, to have a single point of access to the TEFs. And I think our nodes also complement each other in many cases. So the experiments and the assessments we conduct in each node, we can benefit from each other like as a whole.
Well, thank you very much for the answers. I think we don't have much time to go on for the discussion. It was very interesting what you have said so far. And one last question, perhaps, which can be answered. What do you think are the risks in trustworthiness in energy in the coming years as a coming conclusion to this? Could you say something?
Shall I start?
Yes.
Okay. I mean, the problem, the real challenge is that AI, Gen AI has been used. I mean, many operators, many end users, also from the consumer side, tend to use this kind of technologies. The problem is that they tend to use them only for assisting very mainstream applications, like a chatbot, like things that help to sort out some questions and answers. The problem is that these models and AI in general is not used for high-risk applications at the moment. This means that there is not sufficient trust in it. So trustworthiness should also be coupled with the use of these models for critical environments in the energy sector. So for actually, giving the flexibility, for actuating things, for real-time control. These are things that we are quite a lot behind. Having chatbots and everything is something that we have resolved, and we are in a very good stage at the moment. That's my perception.
Oh, thank you very much. Is there any other?
Maybe I would just very, very quickly add that indeed that's I agree with Elissaios. That's one thing that I guess in all the TEFs we're looking at trustworthy AI, explainability concepts. So developing services specifically for that as one of the services offered by the TEFs. Maybe it's also interesting, as I said, then when going into operations, how to translate those from a little bit more abstract principles into operational requirements, engineering requirements, metrics for evaluating what is the minimum level of trustworthiness or of understanding of the behavior of AI. That's one thing that probably within AI Effect we want for sure to address together with the operators, their point of view, their understanding of their responsibility, their expectations. It's also very important. So it's something that requires the different point of views and the different responsibilities and understanding within the TEF and within the energy sector at large.
Okay, so there is quite a lot to do to get to address the current challenges and of course the change in regulations. I think we don't have any much time. The time is over. Thank you very much for the participation and thank you for the invitation for me to be here as a moderator.
And to thank you also for moderating, for your time amidst your very busy schedule.
Thank you very much. It's always very, very nice to hear these excellent presentations from these excellent researchers. Thank you very much.
Thanks a lot.
Thanks, everyone.
Bye.